Topic for today is linear regression. I'm the presenter, Perry Blend. The agenda: in this presentation, we are going to carry out a linear regression utilizing PSPP, importing the data, stating the hypothesis test, rejection rule, and supporting details. Use PSPP to conduct the regression, analyze PSPP's output, and the important takeaways. Importing the data, as you can see, using PSPP. State the hypothesis. For this, we have 3 regression tests we're going to carry out. The first is, can we predict an individual's debt by knowing their income? Dependent variable will be debt, income, independent variable will be income. Second regression is, can we predict an individual's savings by knowing their income? Dependent variable savings, independent variable income. Third regression test, can we predict an individual's portfolio value by knowing their savings? Dependent variable is stocks, independent variable is savings. State the hypothesis. There are several ways to express the hypothesis for a regression test. Regression test, according to Star Trek, states the null hypothesis, the slope of the regression is 0, which means beta equals to 0. Alternate, the slope of the regression is not 0, which means beta does not equals to 0. Or regression hypothesis, there are no significant regressors, or there are significant regressors. Also, we're going to take a stab at the rejection rule, which we have as we reject the null hypothesis when P is greater than alpha, where alpha equals to 0.05. Confirmation rule, that is not within the confidence interval. What it all boils down to is whether beta in our linear regression or best fit line significantly than 0. Y equals to beta x plus c. If it is, then the regressor x is significant, or if it is not, then we do not have any significant regressors. State the hypothesis. The first regression we're going to talk about is debt equals to beta income plus c. We are going to see if debt relates to income by performing linear regression. Whether or not beta is significantly than 0, we also know we can model or estimate debt using income. Thus, far we know debt equals to beta income plus c. The regression hypothesis here will be there are no significant regressors, beta equals to 0. Alternate, there are no significant regressors, beta does not equal to 0. Rejection rule, we reject the null hypothesis when P is greater than alpha, where alpha equals to 0.05. So the confirmation rule, as we can see, that is not within the confidence interval, and so forth. What are we really asking or trying to accomplish? We are asking whether or not there is statistically significant estimation of participants in debt using income. In order to accomplish this task, we will use the PSPP data set by clicking under the Analyze menu, choose Regression, then Linear, move the dependent variable into the dependent box, move the independent variables into the independent list, and click OK. Then insert the values in the appropriate box. In this case, we're going to insert debt in the dependent box and insert income in the independent box. Afterwards, click the Statistics button. Another window will appear. Make sure to check the coefficient, confidence interval, and the R, and click Continue. Then click OK to run the regression. Then the results will pop up. The output windows contain all the needed results, such as adjusted R square, income, regressor, beta, significance, p-value, and lower bound. Please note that we, in the confidence interval test, we likely don't have the regressor. Also check out the p-value, which in this case is bigger than 0.05. Thus, we cannot reject nor fail the null hypothesis. So this is just a demonstration of how we arrived with the data we're going to be using. So for this first test, the result is no significant result was found. Using the forced hypothesis test, the following regression was conducted. A simple linear regression was conducted to determine whether debt could be predicted from income. No significant regression was found based on the values in front of us. P equals to 0.535, which is higher than 0.05. For the second one, we're going to do the same procedure, which is stated right in front of you. Using the confirmation rule, here what we are really asking or trying to accomplish is whether we are asking whether or not there is statistically significant estimation of a participant's savings using income. We're going to go through the same process. This is just to show how we arrived at achieving our data. Here's the data. For this, a simple linear regression was conducted to determine whether savings could be predicted from income, which is regressor. The values here shows that thus the test rejected the null hypothesis and predicted aggression passivity, meaning there is a significant result was found. For the third one, we're going to go through the same process. Here we're going to have stock equals to beta, savings plus C. Again, we have our confirmation rule. For this, we are asking whether or not there is statistically significant estimation of a participant's stocks using savings. Again, we're going to go through the whole emotion. This is just showing how we arrived at our data. Here's your data. Here's the data. And a simple linear regression was conducted to determine whether stocks could be predicted from savings. And the value indicates the test rejected the null hypothesis and predicted aggression passivity. Important takeaway: PSP may be used to carry out a linear regression test. The coefficient of determination R2 provides information about the goodness of fit of the regression model. It is a statistical measure of how well the regression line approximates the real data points. R2 is the percentage of variance in the dependent variable that is explained by the variation in the independent variable. The parameters beta 0 and beta 1 are called regression coefficients. They are the intercepts and the slope of the straight line relating propensity to buy to perceive quality. Simple regression analysis used in a situation where one independent variable is advertised to affect one independent variable. Thank you for watching the presentation. Have a nice day.